want to teach them. But then there's all those other people. And
Yeah.
we probably need to reach out to them somehow. And that's basically the issue that I hope we can try to poke at least in this panel, is what should, what do we think we should be teaching them? How can we teach them? And how do we let people know that, hey, we need to do this? That's the simple 3-point summary of it. I'll admit one of the things that I've been thinking about the last week, and by the way, I have to apologize a little bit. My office computer decided to crash yesterday, so my last week of work has kind of gone up in smoke, and
Oh
I'm
no.
winging it. But one of the things that I was thinking about was the fact that saying everyone, wait a minute, that's an awfully big group. Maybe we need to subdivide it a little bit and start saying, okay, kindergarten kids need this much.
Right.
High school kids need this. Technical people, doctors and so forth, need a little bit more, maybe. So let me not spend a whole lot of time. We have several people joined us, it looks like, I think, and we'll probably have more watching the tape after a while. Excuse me, the video. Someday I will learn to call them videos. They're not tapes anymore. But in the meantime, let's see, should I just go down the list? Andreas, do you want to start off?
Well, yeah, sure, I can start. So hello to everybody. Many greetings from Klagenfurt. I think that you suggested, Michael, that we are starting with a short teaser and a statement. And well, I prepared some slides. Basically, it's just one slide that I want to show to you. So let me just turn that on. So let's see. Yeah, I keep it that way. Okay, so well, how to start? Maybe I should first say that here in Klagenfurt, we are having a computer science curriculum and software engineering is elective. But we were also the first in Austria to start teacher training. And at the moment, I'm responsible for future computer science teachers in parts of Austria. But this is just one issue or one thing. More important is that here in Klagenfurt, we have a very special setting where we are having some kind of Informatikwerkstatt, that's German for computer science workshop, something like that. And in the past 5 years, we had more than 10,000 pupils here in Klagenfurt and a bit more than 4,000 active or also non-computer science teachers. And not only from the pupils, but mostly from the pupils. So we do get questions like this. Why should I learn that? What will I do when I become a software engineer? What will I do when I become a computer scientist? And what we notice here is that active teachers are normally not able to answer that questions correctly. And one reason is that our curricula do not convey the whole picture. And it's totally clear, at least in the context that I know, not only in Austria, but also other countries in Europe, that teachers are not often trained appropriately. So they, of course, are not able to answer these questions correctly. Teaching is, for that reason, quite often reduced to either ICT training or programming, but there is much more out there. And it goes back basically to findings in neuroscience. It goes back to findings in didactics. We have this learning brain, and the learning brain needs the whole picture. And that's the reason why basically, that's my statement. I would say that we should start teaching software engineering as early as possible. and eventually later we can discuss them together what we think that would be appropriate for pupils in kindergarten, primary schools, secondary schools, up to university studies. Basically, that's it. That's my opening statement.
There it is. Thank you very much. That's really great. Okay.
Thanks a lot.
Let's see who's here. Is Don? Yeah, Don's kicking around. Right, you're in the corner. There you are. Would
Yeah.
you like to speak next?
Yeah, just give me a second. I should have had my slides. There they are. Should have had the slides all set up for this. Let's see. I haven't been using Zoom for presentations this semester. They decided now I need to get
In the lower bar, there's should be something like
should be sharing. Yeah, there should be a share presentations this semester. They decided now I need to get now I'm trying to find back to where I was at.
lower bar, there's should be something like
sharing. Yeah, there should be a share. Right. I'm looking at the Zoom. I'm on the Zoom screen. Now I need to get now I'm trying to find back to where I was at.
There is an icon with a camera, a blue camera.
Sharing. Yeah, there should be a share. Right. I'm looking at the Zoom. On the Zoom. I've all of a sudden lost the okay, wait.
There is an icon with a camera, a blue camera.
Right. I'm looking at the Zoom. Somebody, why don't somebody else go and I'll
I think there is someone playing the YouTube stream.
Yes.
So someone has the microphone on and displaying the
Right. I'm hearing feedback.
Echo about 5 or 6 seconds later. So that somebody's playing YouTube.
Somebody else
So-
go and I'll
I think there is someone playing the YouTube stream.
Yes.
So someone has the microphone on and
Okay, that's better.
That was me. I'm sorry. I did
What-
have the YouTube up.
Yeah, why don't we go with somebody else for now?
Yeah, please.
While Don tries to figure his thing out.
Yeah, thank you.
Don, do you want to mute yours and we'll get
Right.
Timothy to go ahead?
Okay,
Okay.
I'll go ahead.
Yes.
All right, great. Okay, sure, super. All right, so if you can see me, hopefully you can. What I want to say is this, and that is that we're talking about software engineering for everyone and showing and teaching everybody in the world a little bit about software engineering who's an educated adult by the time they have assimilated a certain amount of information. Obviously, it needs to start with children. That's clear. But then I said to myself, okay, what do we teach about other branches of engineering? What should we teach about other branches of engineering? Let's take bridge building, for example. I mean, we're all taxpayers. We pay money to have our infrastructure built, our bridges. So presumably there's some benefit in us as citizens knowing about that branch of engineering, at least at the basic level. And some of us might have, the opportunity, if we have a bit of land, to build a bridge across a creek. So we might need to actually build something that our kids could bicycle across on our land. You know, that's the kind of level of thinking I'm thinking of. Bridges are of economic importance. Software engineering is too. And in fact, as I started thinking about it, I realized there's a lot of things that are very similar. And that if we're teaching the one, we should teach the other. And maybe we should teach it as engineering in general, with a little bit on the civil and a little bit on the software, so that people can see it's really the same kind of thing. So if you're designing bridges, you need to know about materials, strength, durability, reliability. Well, guess what? You know, with software, you have materials too. You have programming languages, you have frameworks, you have libraries. Both have math, different kinds. Both have economics, maybe slightly different kind, but ultimately, you know, there's an economic issue there, and we should be teaching basic economic concepts in school. So we have educated adults and voters who know how to think about, well, we're going to be paying for a bridge. We're going to be paying for the government to invest in a brand new, you know, software system for its military or its civil service. Same idea. They only need to understand the economics of this. For bridges, you need expected traffic. Well, guess what? There's expected traffic coming into any software system too. For bridges, you have the environment. Well, for software, there's an environment, there's the data, there's the other systems, there's the hardware. There's knowledge of what has worked well. That's the patterns. You know, what has worked well in bridge building? That's the same idea with software, right? There's patterns there too. And for both, there's artistic and aesthetic knowledge of, you know, what makes it really nice for people. So these are the kind of things that I think we should be teaching in a generalized engineering curriculum all the way through the school, just like we teach physics and chemistry. I mean, why do we teach physics and chemistry? Because we think it's going to be some kind of benefit to people when they're adults. And most adults are not actually going to do new physics, but understanding the basics of it will help with bridge building, just like the basics of computer programming will help with the software engineering. And just continuing the analogy, just for one more slide, there's different architectures in both bridge building and in software. There's loads and load types in both. In both cases, long-range future needs to be considered. Both can be damaged unexpectedly by attacks or accidents, right? You can have a ship crashing into a bridge. You need to design defensively. Well, guess what? We all know about the security attacks on software, right? Design defensively, same idea. And that adds to the cost, by the way. And we also have the fact that, well, things get old and get long in the tooth. And that's the case for bridges and for software. People are reluctant to invest in both. And the lifespan, well, what is the lifespan? Bridge lifespan used to be considered 100 years, 200 years. Now it's probably a bit less than that. Software, well, you know, there is software that's out there that's as long as some of the bridges being retired. You know, it's the way it goes. They need to be replaced. And this is the standard thing in engineering, okay? So that's the core analogy. You know, with software, people do build bridges. You know, not very many people, you know, write their own software. Not very many people build their own bridges, but end users do that. And why do we teach people in school to program? Because some of them will need to write programs as adults. Some of them might need to build bridges. Some of them might need to build engineered things that are low level, not a public safety issue, but still they need to know a little bit about the strength of the wood they're putting across a creek, right? And the same thing with software. So I think we should teach general engineering content from kindergarten to 12, and with some knowledge of software and some knowledge of civil and some knowledge of mechanical and so on. And how do we do this? Well, we need to communicate this to departments of education and to national, and it should probably be done by the various national computing and engineering societies. So that's the end of my little spiel. I'm going to pause sharing or stop sharing.
And a very good spiel, I think it was. You know, bridge builders. Okay. I have to admit, one of the things I was thinking about was spreadsheets. I've had the fun of having somebody tell me, hey, this is just a spreadsheet. You don't need a software engineer for it. Except they didn't put any error checking in it. And my gosh, they ended up with $1 million losses because of it. But, that's another argument altogether. Anyway, let's see. Don, how you doing?
I think I'm ready.
You found that share screen button, okay?
Yes. Yeah, I
Go for
just, for some reason, I lost the entire screen and had to come back in. So I'm good now.
Yeah.
So let's see. Should be able, or is that sharing okay?
Looks good.
Fine.
Okay. Okay, so thank you for your patience. I'm doing this, of course, mainly from my background is in in U.S. education, and so I'm going to be mainly try and talk from that point of view, and I think what I tried to do was look at primary education, and I think that we have a situation where we have students that are learning computer literacy, they're learning math and science, but computer science doesn't seem to be something that's on the radar at a lot of K through 8th grade schools in the United States. I think that trying to, embed software engineering within whatever computer science they do learn, probably at both primary and secondary levels, are probably going to be, the best way to go. As far as what in particular they can learn in primary education is some things about the basics of programming, and within that there are things such as testing and debugging, working in small teams with agile or pair programming and other types of facilities. That's probably the best way to go at the primary level. At the secondary level, we are seeing an expansion, I think, in the US. One thing that has been very helpful recently is that the advanced placement program in the US has started a few years back a computer science principles class, which is kind of like the CS0 class that we've had for many years, the breadth first type class at the college level. And students, I'm seeing a large number in the last year or two of schools offering it, that of people that are coming to visit campus here and such, that they're learning that, and then they're going on to learning Java. But in the computer science principles class, we've got software engineering component in it already built in, and that can look at various types of things. I've got a list on here about I haven't been following along with this very much. Process and methodologies, configuration management, quality assurance, software documentation, computer interfaces. All of those are things that can be taught, at least given them some exposure to, in a class like a principal's class, and then even more so in a full-fledged programming class. And so I do think that there is place in both at all of K through 12 levels to do it. The important thing is about selling. I've been so flustered here. Are we supposed to hold off on talking about the publicizing right now, Michael?
It's okay if you want to. We have
Okay,
2 hours.
I
spend
think
on
the
this.
big thing, I think the
Break it
big
up or put it
problem
together.
is publicizing is, I think, the big thing, and I don't have any really good suggestions with that, except for I think working with current computer science groups that are doing it within computer science is probably the best way to get the computer software engineering essential type of things within. So that's about it.
Outstanding. Okay.
I will
Let's see.
unshare here.
Tony is here.
And Tony's here, so we could probably ask Tony if he'd like to say a few words. All right. Tony? Oh, 1 of 2.
Here he is.
I see a block with his name on it.
Yeah, I see it too. And it's unmuted.
Tony, maybe you have a mute on your microphone too.
That's true. That could be it.
We cannot hear you.
We can see your slides, but we still can't hear you.
Yes. No, we can hear you. Oh, that's right. I'm sorry. Mix up my people.
It's an English accent, but yeah.
Yeah.
Tony, we can't hear you.
Technical challenges.
Tony?
I don't know if he can hear us saying we can't hear him.
It doesn't show him
I
as
just
muted.
sent him a
on-
private message
Yeah,
that we cannot hear him.
Yeah.
yeah. Well, we can look at his slides at least. So these are the things that he thinks everybody should know, which makes sense. Professionalism, team roles, structured development, functional requirements, non-functional requirements. Makes a lot of sense to me.
Just let me try to help you. On the left-hand side, there is a green icon. Click on that green icon. And then on the right-hand side, there's a wheel for, I think, well, it's in German, maybe options or something like that. And then if you click on that, there's audio. And then you can maybe change your audio microphone. Maybe you have a wrong microphone setting. It's the third entry from above.
It does depend on what platform he's using, though. If he's using a Mac, it will be different.
Okay, I just downloaded the app, the Zoom app.
Yeah, well, I'm using the Zoom app on a Mac, and it doesn't look like what you described. So, yeah, maybe I might politely suggest that we go on to another panelist. I don't know if Tony even knows. That might be he has to unshare his screen.
This may be the one slide.
This may be the one slide. So we can see it what he's saying, but it'd be sad if he can't reach us in audio at the end.
Right.
Boy.
Okay, I think those are the four that I think we have who are all here.
Okay.
I can say a few words. One of the things that I thought about was, which kinds of things would I like to try to teach or avoid teaching? And I kind of put together a short list. One is, and this is kind of silly, but some years ago, I was asked to tutor a vice president from a hospital. He was a vice president in charge of purchasing from a hospital. And he was taking a course in computer fundamentals. His hospital thought that you should understand something about these computers. And in meeting with him and going over where are you, what kind of problems are you having? The thing that he could not seem to get through his head was the idea of step-by-step process or sequence. If I ask him, what are the 5 tasks that somebody needs to do to make a cake? He would tell me, and I'd say, okay, which one do you need to do first? And he didn't seem to quite grasp that. And I finally told him, look, the computer is stupid. You got to tell it one by one, step by step. And I said, okay, what about this? If you had an assistant or a secretary that wasn't real sharp and you had to tell them step by step what to do, how would you do it? And he said, I'd fire them and hire a new one. I kind of went, okay. And he sort of got it. He guessed, frankly, on most of the questions in that course about anything that had to do with sequence, but he just missed it. And to me, it's such an obvious thing. You're going to do number 1, number 2, number 3, number 4, and yet I have run into people who don't quite grasp that somehow, and I think I'd like to teach them that. A similar related thing is there seem to be a number of people who believe software, and especially the software that we all use every day, has some kind of magic in it. If I hit the little microphone and I talk to it and it doesn't get it, maybe I didn't say it right or something. There's some kind of magic there. Again, some years ago, I walked in and I was supposed to be looking at a computer that was not working well. And I sat down and I started to type at the keyboard and it didn't react. And I looked at the guy and he said, oh, you have to hit the table 3 times before you type. And I said, what? And he said, he whammed the table really hard. And he said, now type. And sure enough, it worked. And I told him, I'm going to reconnect your keyboard before I leave. And he said, no, it's really, you have to hit the table 3 times. I reconnected the keyboard before I left. I suspect they are still hitting that table hard. It's like, what? And I'd like to get that idea across to people that there's no magic here. It's a very logical, sensible thing.
There is someone raising a hand.
Okay.
Yeah, please.
Gerhard.
Yeah, I think it's the most important thing, these mental models in the society, that they understand what they can and what they can't do with computers.
Yes.
With software engineering.
Yes.
I think this is the thing that we really have the responsibility to get over to a lot of people, because otherwise society makes choices that are just, in our opinion, wrong. So we have to educate, especially politics, and people who are making decisions currently, and of course educate everyone with at least some amount of understanding basics of how things work.
Sure.
And it's often not happening. At least in Germany, I've sometimes for me, it's like politicians make decisions that are just plain wrong. What you can do with computers.
Sure.
For example, we had this Twitter password stuff and so on going, and it's just incredible that even highly educated people don't grasp how passwords work and why they are bad, and that you shouldn't share them. It's just
Yes.
incredible.
Yes.
From our point of
Politicians
view,
are wrong about so many
computer science
things. People, educated people can be wrong about so many things. Just look at some of the people that get elected and do the electing. and our whole primary education has to be about, breadth and core concepts. And there's way too much to learn in modern society for us to learn everything. So what we have to do is we have to make sure that we teach people what will be the root things that are the most important, so that we have people who are capable and broad-minded and don't do stupid things when they're adults.
Yeah.
Right.
But that's the reason why I'm not seeing that everyone has to be a real programmer. Wouldn't be my choice. For example, using Excel a bit is really helpful, because that level of understanding that you have to do things step by step, that you can really make something more complicated out of something simpler. So for me, using Excel is, I would say, from this kind of mental models, extremely helpful, and it also helps you in the real world for a normal life. So if we get things into their life that is easy and usable for them, they are faster getting a certain concept than if we tell them about agile or whatever, because I don't think 95% of people going to school nowadays will really be programmers. So I would rather take things that are easy and usable.
Okay, that's a good point, except that that could be an argument for saying that, well, we shouldn't also teach chemistry and physics in school, because hardly anybody is actually going to be a physicist and a chemist. It's a question of, how much do you need to know to be an educated person so that you can understand what's going on around you? And I think that a little bit of programming is something that everybody should know beyond just Excel. There's two problems with just learning Excel. One is that you get to a certain level of complexity of a spreadsheet, and then you really, really struggle with complex formulas, when it would actually have been simpler to write a little program
Python
to
or whatever,
do the same thing.
Yeah,
sure.
And the second problem with Excel is that a little bit of diversity also helps. So knowing a different programming language as well as Excel can say, it's the same concept, and that leads you to be able to say, you know what? There's a dozen programming languages out there, and if I got these two, I've got this Excel, which is sort of programming in some way, and then I've got say, whatever basic program, even if it's something very simple like Scratch. Maybe I can also do something more sophisticated. So it opens up the world for you.
Yeah, I absolutely agree. It's just where do you start? And for me, for example, people can make more use of Excel than Scratch in the real world.
Okay.
Yeah. That's the reason why I would start with something so simple like Excel, and I wouldn't stop there typically. I have 3 children, and two of them are 10 and now 11, and my oldest son is 16. And I was programming when I was 12, more than my oldest one, and I'm really a nerd in a good point, in a hopefully good way. So I'm really trying to teach them a little bit of a Raspberry Pi or whatever. And it's not so easy, because the world has changed so much that everything is connected, and you can use it in certain ways that are not what parents sometimes like, YouTube watching, whatever. So it's also dangerous in a certain way to teach them quite a few things, or give them time to like I was when I was young. I was trying out everything, and it was okay because it was not so addictive. So I think it's gotten harder compared to when we started with computer science.
Oh, definitely.
Or with computers in general.
Yeah, I'm
I
exactly like
fully
you.
agree. But that also means that we need much more teacher training. Yeah. So when you say that there is quite a lot of danger also in these new technologies and the way how pupils can deal with these technologies, then I would say, well, we need to bring it or we have to do it right in schools. And just to add on one thing that Don said, so because there was this question how to publish software engineering or programming to the masses, and he said that, well, okay, so we need to bring it to the computer science teachers, and I fully agree, but not only to the computer science teachers, to all teachers.
Yes. And then that's the problem that there are not enough computer science teachers anyway. And the computer science that I got, that I see currently with my children, is just plain senseless, I would say. It just doesn't have anything to do with computer science. It's how to use PowerPoint and Word. I would say that's something you can learn, of course, but they are not learning typing at school. I think it's ridiculous. You should start with something like that compared to a lot of other things. So, but still, it's to change that. It's really hard because most teachers, per se, are not willing to learn new stuff because they are teachers. Yeah, it's the personality in teaching that hinders you often enough, not always, of course, but often enough to learn new stuff. So, at least in Germany, I'm currently a little bit in this. We try to. I'm currently trying to change the education system a small bit. And from the interviews that I do, the talks that when I talk to people, it's like teachers don't want to share how they teach. They don't want to share their material. They don't want to allow anyone saying to them, you're doing something wrong. And they don't want to learn something new.
Yeah,
and that hinders the whole system of changing. And it's really a nightmare. So, and this system is helping each other. So there's no pressure on changing that. That's a German view. I don't know if it's like this anywhere in the world, but at least in Bavaria, in Germany, I see that a lot. So I don't understand why there's not more education material online for the whole classes and so on. And that's also probably the reason why at least Germany has some difficulties with this coronavirus at schools, because there's not good enough content online and teachers are not used to sharing and giving them feedback and getting better.
It also holds for Austria, but maybe I can pass over that question to the other panelists.
I think this is a human problem, probably not a German problem or an Austrian problem. I think that if you look at the spectrum of people who are, and we don't need to just say teachers, I look at even doctors. There are some who are actively learning and want to continue and are constantly seeking new information and want to try new things. And there are ones who want to just do things the same old way that they learned it in school and they won't learn anything more. And some of them, because it's just their personality or the way they've been trained, and others, it's because they're just overwhelmed. And a lot of teachers are actually completely overwhelmed, especially during the pandemic. And you try to get them right now to do anything new, forget about it. But even in a normal time, many teachers are overloaded. I have one of my sisters-in-law is a teacher, and I know several others. And I think as a professor, I get overloaded too, in a different kind of way. I do less teaching, but I do get overloaded. And there are times when I can't really take time to learn stuff I really want to learn. But with K to 12 teachers, they got to be in that classroom, 90% of the time, and then they got to mark stuff, and it is incredibly overloading. And to expect them to change and learn new stuff is very difficult.
So my suggestion would be to create commonly material that is extremely easy to use, extremely easy to understand and use that and give that to the masses, to all teachers, to computer science teachers, and have material that is tested. So like normal science, how if it's good or not, and how it can help in certain ways for different school types, different experience levels, and really create open source common teaching material. That would be my suggestion, how to increase fast the knowledge and the acceptance of computer science. This is at least my way of thinking currently, that could help, because it must be extremely easy to use this stuff and to teach this stuff without much time, effort. And it's known that it's okay from the content. It's known from the pedagogical way of doing things. Having video lectures if teachers don't want to do that themselves, so that you can make flipped learning concepts. Have some experts that teachers can get to, and going that way, like open source, like what Timothy yesterday really showed in a great tutorial, how you could really increase domain modeling or modeling. It was incredibly cool, Timothy. And I think going in this direction, but with a much lower, it must be a masses thing. Yeah? It must be something that really is available for everyone at 50 languages, is proven. There should be some experts who are continually making it better, something like that. This could have impact.
Absolutely, completely agree with that. Yes, definitely. And in fact, by doing that, you're offloading the teachers. Yes,
exactly.
You give the teachers a chance actually to take a break in the classroom and have the students do something interactively with the teacher guidance, and then the teacher can come back in again and help the students, and the teacher can be learning this stuff at the same time if they have to. I mean, ideally they know it, but we know in reality is they often don't.
They can learn with the students.
They can learn with the students. I mean, as a professor, I've learned stuff just ahead of students before on quite a few occasions. Sure. So yeah.
I'm from the business point of view. As a consultant, you learn the stuff 2 hours before the client. Sometimes it's just okay.
Yes, exactly.
And it's okay. It's really okay.
It is okay, and we need to admit that, because some people will look at us and say that's intolerable, but in fact it's not. It's the reality. And it's the same. My father was a medical practitioner, retired recently, and he used to sometimes learn stuff relatively shortly before. He'd say, I got a patient with an interesting problem. I'm going to read up on it, on this particular disease.
Normal thing of working.
It's the way it is.
It's in a complex world. That's just normal. And I think this has also an impact. If we do it good in computer science or in whatever, how we call it, it might have also an impact on other curricula. Because I think it's the same problem for other curricula as well, not for computer science. It's in general in education, to increase, make it better, to have this not in for every Fach. My English is a little bit rusty.
Subject.
For all subjects, thank you. Sorry. And so I think that could democratize learning a bit more and increase the levels of understanding a lot more, and also but how to start with that? It's in every country, in every school system, you have different expectations and different ways of doing things, and it's not so easy.
Nowadays, I'd almost suggest maybe we need a YouTube channel and some games, and start laying out what we want them to learn there. But yeah, it sounds like we need, I don't want to call it the SWIBOK, but a body of knowledge that we think should be available to the students at whatever stage they're at. Interesting.
And also playing with it in the real world. So I'm a huge fan of the Raspberry Pi, for example, because it allows you not to only make mental models about something that is not changing our world, but really having something that you can put your fingers on. And this is a huge game shifter for a lot of people if they can do it and see that working with computers has an impact on the real world. So making this stuff available not only in English, but also in other languages, and also a lot of things that you could try out and really, find your own ways of doing things. So not only you get something as a basic instruction, but also something that is a little bit more playable and also open, because I think we need this mental model of trying things out and seeing what works is a little bit better than just having, sorry, Michael, a YouTube channel with fixed content. It should only be a starting point for own experimentation and own things where you start doing your own stuff and learn by doing, and not only learn by learning like the normal stuff at school, where you get something in one ear and it goes out on the other. And
Yeah.
in Germany, we have this saying, Bulimie lernen, learning, you learn something, you spill it out again immediately. And that's how I, at least in Bavaria, experienced school.
Yeah.
It's funny, you know, because I have a 9-year-old daughter. I have 3 daughters. The youngest is 9. And she is absolutely super expert in Minecraft, which is a video game. I'm
Yeah.
sure everybody knows it.
Yeah, sure.
If you have kids. She is like an uber expert. And I'm just amazed. I can't possibly hope to do anything she does. How did she learn? She learned by watching YouTube videos of people playing it, and then practicing and practicing and practicing and practicing. And not only does she know everything about it, but she's super fast at interacting with it and can, you know, build stuff that's amazing. Like, I'm saying, oh my gosh, if only you'd applied that approach to, you know, computer programming or whatever else you want to do. I mean, for crying out loud, you could be a concert pianist by now. So, you know, the kids are motivated. And especially if there's some kind of gaming and some kind of society. I mean, kids watch people on YouTube playing games, and that's how they learn to be good at games. So what we need, perhaps, is people watching virtuoso programmers who are also social, because these gamers who do YouTube videos of themselves tend to do it together. You know, virtuoso programmers programming together, and maybe they'll get a following of people. Just an idea.
I think Jan has a question.
Yeah, maybe if I can chip in on it. I think like there is a curriculum available. There are textbooks. There is material even that teachers share. Maybe I'm coming from a privileged situation where my computer science teacher was also writing the textbook, but they had some materials. But I think the major issue is that, I don't know, like computer science in Germany, I think starts with more computer literacy in the beginning, which is not computer science. So this separation first place, and what kind of starts as programming, stuff like using Excel, is just not something any 9th grader or 8th grader wants to do. They rather want to, I don't know, build like a mobile app, a game, anything like that. And I think just kind of changing the like still doing the same concepts, object-oriented programming, anything like that, databases, all of this, but in a context where they see how this makes any sense, and not just something they just don't care about, some old people stuff, kind of from their perspective maybe. That might even do the trick already, and I think there is material out there, but on the other side, it's also limited from the curriculum, what is kind of should be taught there. So I don't think it's just like I just make something up and teach it 5 minutes later. I'm not quite sure if that works with the way our education system works, but just like modernizing the kind of those exercises and bring that in like a fun, children popular context might be a quite big factor.
And also having the possibility to do it, because in the schools where my children are, there are not enough computers or whatever at school. So at home, most of the students do have computers, but not at school. So compared to what we have in that industry, it's extremely hard to see that this level of how you interact with other people, how you interact with computers, with infrastructure, is just not there. Yeah, so we have to update a bit also the physical world to be able to learn in the new modern world. I bought my son's the iPad Air now that they have something to play with, but only one of them, the oldest one, is allowed to use it at school. So they have a computer room for the whole school, and that's it. And they have a 30 megabits for the whole school, and that's it. And compared to what I do have at home, it's just I do have more computers probably as the school at home. And my internet is faster than at school.
Yeah.
So there are a lot of things that have to change if you want to have an impact.
Agreed. My 15-year-old takes her own laptop to school and uses her own cell phone to connect to her laptop rather than using the school's Wi-Fi for the same reason.
Yeah, it's standard that this is problematic. So to change that, you have to change how education, how science, how computer science is looked at all. The education in society has to get another view, probably.
Patricia is raising her hand.
Hi, can you all hear me?
Sure.
Yeah.
Okay, great. Yeah, I'd just like to jump in here. Similar to Gerhard Müller and Jan Philipp Bernius, I have two daughters who went through or are in the Bavarian school system, and I share your frustration. The first years, say like the 6th, 7th grade, they were learning things like Microsoft Word and Excel, but a lot of it depends on the individual teacher. In the 10th grade, my daughter finally had a young female computer science teacher, and what they did is the entire class programmed a game. Each group of, say, 3 or 4 students did one level of the game. And at the end of the year, they brought the game together. This was something that was fun. It wasn't something boring like calculating exponents or plotting logarithms. This was something that they could have a good time with. And today, if you use a lot of libraries, you don't have to spend your time moving the cursor like Robot Caro. What they started off with the interface was like something from the 80s. But you can actually use libraries so that you just include a bunch of libraries and they get this immediate positive game feedback. We've also used this for like our Girls' Day at the university. We invite students, pupils from high schools around our university, and I've had them use libraries like Alice from Carnegie Mellon. It's a teaching tool, but you have a lot of objects that are already there, and you can point and click, and very quickly you get the visual feedback. Oh, I have, a game that I made with a bunch of trolls and a bunch of goblins, and I'm running through a labyrinth, but without actually consciously programming. You're doing things like what we talked about, like thinking about sequences, what has to happen after one after another. You're thinking about things like if, then, else. You're thinking about things like repeat something until, and so they're learning these programming concepts, but in a fun way.
So I know this interface and or the framework, and that's really great to motivate boys and girls, especially girls, right? Somewhere in the chat, I read a question that says, or that goes that way, will the situation change in the future? Because at the moment we are complaining about our school systems, and I think the good news is that the situation really will change. So the new generations are much better educated. I think that also computer science didactics is now much farther than 10 years before. So what did I want to say? Yes, and also teachers from other fields, they are now getting the portions of computing science. So in Austria, for example, for every teacher, and it could be religions or sports, they also have to do some computational thinking. They also have to attend classes with information and communication technologies. So it will change slowly, but it will change.
Well, is it fast enough? Is it fast enough for society? Yeah,
Well, no.
We don't have
No.
time anymore, in my
I
opinion.
fully agree. Yeah.
So
Probably
I'm
not
not
fast enough.
accepting change in 5 or 10 years. It's just too late because we will make so many mistakes in other areas of society if we are not speeding up. So
Okay.
time is not something we have, in my opinion.
I fully agree. And also my son, he's 10 years old now, came back home from school last week, totally embarrassed. And the reason was that he had his first time now this computer science class. And what the teacher asked them to do is to mark something in Microsoft Word and have it bold formatted. And with 8 years, he started to learn Scratch by himself. He now started his own YouTube channel. He also founded a company, a gaming company, and he hired now other pupils from school so that they are working together with him on the next game. And then he entered the classroom, right? And computer science teacher there, and everything that he needed to do is mark something and make it bold. He's now really embarrassed, and I tried to calm him a bit, but anyway, yeah, that's the situation, I know. Well, statistics tells us that in about 5 years, most of the teachers, at least in Austria now, will retire. So computer science teachers who are not really computer science teachers, you know, so it's the strange situation in Austria that there are teachers from different fields, and they got some teacher training for just a couple of hours. Anyway, they're going to leave in about 5 years. But Gerhard, I fully agree with you. It's not fast enough.
Well, that leads me to the difference between computer science and software engineering. So the question was software engineering for everyone. So computer science is quite well known about programming, you know. But software engineering is a bit more. Software engineering is about abstraction possibilities, coming up with new processes, you know. When we had the COVID problem on the border, yeah, during midnight, we had to fill out some forms, and they said, okay, you're coming from abroad, from the southern part, you have to print a form and fill it out, yes. They have a smartphone with them, and that was it, okay. And they said, okay, what there's just some kind of, you know, common sense needed to come up with a solution. Just send our soldiers, but they were soldiers, you know, our soldiers with a bunch of paper just along the row, and then it will be easier to do that. But they didn't do it, you know. They had just three persons over there, and they had their own paperwork they had to fill out. They couldn't read the names, and that was awesome, you know. And so software engineering is more about also not just the computing stuff, you know. It's about people. It's about we also write software for people to use, you know, and people are affected with software. They don't need to program, but they should know what they can do with it, what they can, as Gerhard said, what they can expect, but also they might be educated in, well, some kind of abstraction possibilities of learning to use common sense, of trying to come up with processes and own processes, not just the control structures and programming, you know. It's for, well, a level above computer science, I think. Mm-hmm. And that's a big challenge.
And this is most important from the didactic point of view. This is the answer for the why dimension. Why should we teach something?
I wouldn't say it's above computer science, though. I'd say it's in parallel. I mean, I started off this morning talking about the general engineering analogy, and I think that this general engineering concepts, including the people concepts that Elke just mentioned, and the economic concepts and the abstraction concepts. These are all general engineering concepts that I think should be taught. And so people can, in fact, can understand what engineering more broadly is about, as well as what specifically some aspects of what software engineering is about, and then separately how to program, as a core part of computer science. I'd like to get back to one point that Andreas mentioned. He said his kid got into a class and the teacher said, "Oh, here's how to bold in Word," and I completely get that. That is, wow, that's like asking me today to go and learn how to do handwriting. Yeah, I get it. But here's an interesting thing: the number of computer professors and graduate students that do not know how to use styles in Microsoft Word is phenomenal. Why not? I mean, styles are such a fundamental thing if you want to do proper word processing, but people do not know it and do not use it.
Okay, thanks a lot. I will tell it to my son.
Everyone should start
Before we
using
lose
LaTeX.
track of it, Ben raised his hand about, I think it was 5 people ago. I'm not sure. Ben, did you want to say something?
Yeah, I think I've enjoyed the discussion. Gerard, when you made your comment about the urgency, it made me think of global warming, and we haven't succeeded there either, right? So it's
We
kind of
have to as well.
interesting. Yeah, I agree, but we do need to. I think it's a little bit more urgent on the global warming side. But anyway,
Probably you need the solutions of computer science and how you work together to do that. So
I agree. So I shouldn't compare them, but Elke, I think it's interesting the contrast between computer science and computer engineering. I come from industry. I was in industry for many decades, actually, and I've worked at various companies. And one thing I've noticed, when we hire people, there's no difference. Like, you hire people you look at people, and if they have a computer science degree, computer engineering, software engineering, you interview them kind of the same way. Now, granted, the skills are different. They are different, right? But I do notice, like in K through 12, we don't really separate chemistry from chemical engineering. I mean, what we teach there certainly is a difference between chemistry and chemical engineering, just like there is in computer science and software engineering. I do wonder, certainly it's the skill sets are different. And I think there are some engineering concepts in general that apply to computer engineering. I just wonder if it's important to make that decision so early on.
Well,
the question for me is, at least how we hire for talent, not for knowledge, because there's just not enough students, whatever, who did computer science in the world. So we go for bright minds and not for concrete knowledge, and we try to have a system where people can learn and have the ability to learn. So we look for people who learn fast and can have good ways of interacting. And then the rest will follow. That's how we do it. So we are not looking anymore for computer science students, not at all. And I would say most of the people that we hire are now physics. And they have done quite a bit of programming as well, but from a computer science point of view, it's dramatically bad. So no version control, not test-driven development and so on, but we are able to teach that quite fast, and then it's not an issue anymore. So that's how we do it in that industry. And we at least now are 460 people. I'm one of the founders of the company.
Well, I think that's also a question of personality. There are people who like to program and don't want to talk to people.
That's not true.
And,
Please don't say that. It's
sometimes,
just
you
plain
know,
wrong.
and,
Really, please don't say that in public. It's just wrong that computer science people are not talking and not like talking. It's not my experience, and I'm really unhappy of people telling that because
well,
it's just
I'm
plain
working in
wrong
the
in
field
my
of
experience.
requirements engineering, you know, and I'm trying to bridge the gap between the people needing something and people try and come up with something, you know. And there is, well, I'm always, well, 80% of the time, I was working as a liaison officer of the client, of the users, in being in, well, trying to help them come up with good solutions for them, you know. And I had to negotiate, help them to negotiate with the developers, you know. And that there is a difference. There is a big difference between those having a problem and those having to solve the problem, you know.
Teach them design thinking, teach them lean startup methodology, teach them business model thinking, teach them change the world, make things better, and the rest will follow.
That's software engineering.
Yeah, but you have to do it. So if I don't see a lot of curriculums in software engineering where design thinking and in startup methodology and psychology is really a big part, and that has to change, in my opinion, if you really want to change the world.
That's why we are here. Software
Yeah, then
engineering.
go out and learn design thinking and this kind of methodologies.
It is the point where I could give also a comment. Rüdiger, I'm from Siemens AG, and we have a session tomorrow exactly on that. Because in 2006 we started we developed so-called core learning program for senior software architects. Core learning programs are kind of high quality programs where we have also a certification in the end. So the senior software architect program runs across 4 weeks, not always completely filled, with practice phases in between. People do homeworks a lot. They have to provide design essays and stuff like that. And yeah, what is the content of that? It's a broad range, starting from business understanding via requirements engineering, architecting, testing, and social skills. Because we know that social skills is extremely important for architects. They have to lead a team without formal power, and this needs a lot of communication and motivation, leadership, and stuff like that. And this is part of the programs. And later on, we developed also one level below a software architect program. And I came in the game by developing a system architect program, where system is mechatronic system. Everything which Siemens produces, like trains or power generators, power transmission lines, automation systems for industry or buildings and stuff like that. So it may be completely software. But if people are talking about or dealing with code, they are more software architect candidates. If they think about how to distribute the functionality across many tiers in the system, so they are more in the system architect program. But in any of these courses, we have this combination from business understanding to social skills. It's very important not to think only about technology, but also about the rest of them. Clarify the problem first before you start implementation is one mantra in my course.
Okay, Gerhard, maybe you want to answer first? Yeah, sure.
And I think a lot of more people should learn how to work together. So I'm a big fan, for example, of liberating structures or sociocracy 3.0, just to learn how to organize people. Because as we all know, the architecture of a system will follow how people interact. So you have to really go back and see how people work together, and that in a scaled way. And that also helps society to know how to do that. So I think we should really go back to things like that.
Okay, so just a comment on the social aspect. We were very lucky because we had the chance to test for personality and social skills among programming contest winners. and attendees in international programming contests. And we found out that the winners always had, well, always. So there was a very, very strong correlation that's formulated that way. They had much higher social skills than those who did not win.
Mhm.
I agree with that.
Yeah, it's
And I
roughly
think
20% of our course content, and this is a very important thing.
And I think we should also have try to say in this society that something to do with computers is not that, but working together. And sometimes this is just perceived in a certain way, but it's just plain wrong. So because of the complex problems in the world that you only can solve together. So I think if we are not working on that, we will get the wrong people doing important stuff in the world.
Reality, you often see architects working in kind of ivory tower, no? And they
Yeah, that's
develop some concept
really
and then throw it
dangerous.
over the fence, and that will never work. So this is also
Yeah,
the
this is not an
mantra:
architect,
involve
that's
stakeholders from day one. This is very important.
Yeah.
And make them work together. When I was working actively as a system architect, this was exactly the same thing. We had the senior developers of all the departments, which later on would develop it. We had the integrators, testers, partly production people. They all became members of the architect team. And then they later on, they became the ambassadors in their teams to defend and make it happen in the architecture. And that's really important, working together. And involve all the key players in the game across the whole life cycle, ideally.
as probably a suggestion how you could tell this or make this happen in the world. If we have social things to do or open source, the way how open source, we have quite a few Corona and whatever hackathons in the world, is really how people work together to solve bigger problems. And then they typically see something like GitHub and they know how to do a pull request and reviews and so on. Try to create an impact with what you're doing. And I think this will motivate people to learn how that is done in a good way. So the intrinsic motivation, we should leverage that to tell stuff.
Somewhere in this discussion of social positioning, one of the things that I am a little concerned about is if you look at movies and many of the fictional portrayals, and I've had people tell me this, oh, you're in software engineering, you're a hacker, right? And I go, no. And he says, well, you go in your room and work by yourself, right? No, not really. And it's like, wait a minute, where did you get that picture? Well, the movie showed me that's who does software. Oh my gosh, wait a minute. I think one thing we might want to consider at some point is helping Hollywood and so forth to a more realistic portrayal of what goes on when we're doing software. You know, what is this? And avoid the fear of the hacker. It's kind of amusing to me that people tell me they're terrified that there will be hackers stealing their money or something when they get a phone call. And I say, okay. And then they show me, by the way, I just opened this email and I can click on this link, right? And I go, whoa, no, whoa. Do you know where it came from? No, do I need to know that? Yes, you do. Okay. We have a terror of hackers, these secret hackers that apparently live somewhere, at the same time that people are perfectly happy getting messages and filling out forms and stuff, you know, and it's kind of strange. Anyway, that's kind of a sidelight. Go ahead. Who's next?
I don't know if I hear hackers being equated with the precise term software engineer a lot, at least in recent years. I could be certainly, I could just be too sheltered from that. But I guess that generally, I guess I don't hear the term software engineer being used in cultural type of situations like you would at one time. And I guess I hadn't really even thought about that until just now, that you really don't see that. You sometimes, yeah, you sometimes, but it's not, the term isn't used as much as far as for the type of things that, you know, like hacking and other things that we hear them called programmers more, coders. I think it's interesting how much the term coding has become, you know, where, you know, equated more to programming than than it has the last 10 years or so. Now, does that mean that, you know, people shouldn't be learning more about software engineering? They probably should, but I guess they maybe need to be hearing the term more.
Just to add the comment, all people are named software engineers. I'm also working together with HR people in the area of competence management for example, software people.
Right.
And there's a big discussion, what is the correct name, software engineer or software developer? It depends on the country. In the
Right.
US, software engineer is more the right term. In Germany, you would call them software developers. We need both names of them, and architects are the ones who do the design of the software architects. But of course, all of them can do any of these jobs.
Right.
I would say it's a role name. It's not something that someone is.
Exactly. Sorry.
And distinguishing between roles and positions, for example, is really, I think, an important distinction. And that's the reason why I also like things like Sociocracy 3.0, because it just makes this distinction very clear. And also how to work together in complex environments. And just basic, it's some patterns how to do it correctly. It's common knowledge. Do you know all that, Sociocracy 3.0? Who knows it? Okay, perhaps have a look at it. I've put a link in the chat. It's really great stuff, and it's open source. It's available for free. It's nothing special.
Yeah, I remember hearing about that a while back. Now I see the link, but I haven't looked at it.
Maybe the distinction also is quite a historical one, because historically you had this face models with the upper faces and the lower faces, you know. And nowadays with agile technology, it's blurring, you know. And the people doing that job have to become generalists and not specialists. You had the requirements engineer who can talk to people, and you have the designers to have the big picture in mind, and then you have the programmers have to follow the way the designers were leading you. And now it's becoming more flat, you know, and everybody has to know a lot of all the different kinds of subjects.
Yeah, on the one hand side, in an agile team, you want to have this cross-functional teams. People support each other, but we shouldn't come up to the idea everybody can do everything. This will not work. Because if you look into highly competitive environments, like, for example, soccer teams, how was it in the past? 30 years ago, we had the forward waiting in front of the foreign goal, and then when the ball came, it tried to kick it in, and the defenders were in front of their own goal waiting for the others. But in modern teams, they still have forwards and defenders, but they help each other. But you still need the specialists because they concentrate on their own thing, even though they spend some time to learn for the others. And it's just, I think it's the same in development teams. No? You will have maybe cross-functional people who support each other. You still need dedicated testers and dedicated developers. If I look in our test sessions, they have more than 30 specific test methods, which can find up to 10 times more failures than just doing testing by chance. But to learn all these things and know when to apply them, so needs a lot of effort. You cannot educate everybody in all these things. Also, the developers have their things, and the product owners have their skills, and so on. No? Still, yeah, they should support each other. No?
They just need to know what the others are doing, and so that the interfaces are clear. Yeah,
this is important. This is very important. Therefore, we have these testing sessions also for the architects, and they have to talk to each other and support each other.
And they have to test the architecture.
Yeah, testers need to do the reviews on the architecture, but also testability has to be designed in.
Yeah.
So going to
if you're really
suggest
coming from a test-driven way, then I wouldn't agree on everything that you said. You can also test architectures by writing programs. Have a look at ArcUnit. That's a library, open source, that we have written, and it really helps as an architect to at least say a few words about the structural integrity, conceptual integrity, and it's just programming. So the way of expressing yourself is source code in a modern world, at least often. And I would say that, therefore, if you want to test an architecture, you have to have a lot of programming skills, and it only can be done by people who want to know how the architecture is working, and therefore you have to program it, like everything else. Software is process knowledge. Process knowledge is software nowadays.
It may start with a simulation.
It's not changing anymore, and that won't go away anymore.
I was going to suggest that one of the questions about positions and so forth may also have to do with size of an organization. I started with a very small Beltway Bandit near DC, about 200 people, and fairly often you walked in and somebody said, well, today you're this, go meet with these people. I still remember walking in one day and being told, Mike, you're going to be a senior systems analyst and you're going to go meet this guy at the Pentagon, where I spent the next year and a half. And I was a senior systems analyst as far as he was concerned. But anyway, small groups often play games with the names, put it that way. Let's see, we have about 25 more minutes. No, 35 more minutes.
Right.
And I'm not quite sure how to pull all this together into something. Do we need to pull it together? I'm not sure. I think we've got a lot of interesting information here and a lot of useful viewpoints and stuff. And the good part is it's all being recorded, so we can go back over it.
So in
really,
10 years,
John, it is a good thing.
In 10 years, we'll be able to look back and see if we've done any of the stuff we said we should do.
That's probably something that we really have to look at. Do we really do things that change the world fast enough? Are we really coming to an action? Are we really thinking about effectuation? What are our possibilities? What can we do? What can we lose to get things started? And I really think that is tremendously important to really get starting to do something about the things that we value. And I'm not so sure if this is happening in the world enough.
It is a challenge. I mean, I remember maybe 30 years ago, there was a move by some people to say we should be teaching basic finance to kids in school so that they know how to manage their bank accounts and their investments and do their taxes and stuff like that, because so many adults don't know how to do these things properly. And today, I don't think anything's changed, right? So, you know, the question is we're pushing against inertia, and we have to see if we can do better than maybe the business finance people were able to do.
Yep.
Considering I heard a podcast just last week recommending a website called youneedabudget.com, and saying everybody should go there and learn how to make a budget. Yes, it's a problem.
Even thinking in budgets is often a problem, because if you do product management, thinking in budgets is not helping you. So at least in my experience, in our company, we don't have budgets at all. Thinking in budgets is mainly, in my opinion, just in a lot of circumstances, just wrong. So if you do budgeting, yeah, of course, you have to sometimes think about it. It's not something that you should be fixed for a year or something, but should be very flexible and depending on the needs. And therefore, the current way of doing budgeting once a year is just plain wrong to get new ideas out.
Yeah. Tracking over budgeting. It's like, you know, working code over big documentation or big planning, you know.
So what we should do is invest a lot more in product management, not in project management. That's some of the fallacies that we always talk about projects, but what we really do is normally products. And we should think and act for working products. And this is is something that nothing is finished typically in software engineering, nothing. Sometimes an increase of a database from Oracle 9 to 11 or whatever, that might be a project, yes. But what we do with software is typically finished when the company where the software is working or the organization is not existing anymore. That's the typical end of software. And that's exactly how we should treat things, that they have to stay for years or ages sometimes. And have this knowledge management and this process management continues over several decades often. And we are currently in the phase where we start losing the knowledge about the stuff at the beginning of computer science. And it's a huge problem, at least at our clients. And we have to mitigate these risks because otherwise the society will rightfully say computer science are stupid because they are not able to manage the easiest things. And this is also something that has to be to get into the knowledge of more people to understand the impact of not doing this correctly, because for society, it's a huge problem.
Ben Reed is waiting for.
Yeah, Ben's waiting.
Sorry. You're muted, Ben.
Yeah, I don't know if I should raise my hand or not, but I think, Gerard, I love your points, by the way. But I think it's very interesting, your point about the budget, because it's interesting too to look at how different companies do software engineering, and a lot of them are extremely contradictory. Some companies have extremely high bars for quality, for tests, for code coverage. Other companies, it's like when it's 80% done, you ship it. And, you know, if you're shipping code and you're not getting a bunch of bug reports back, you waited way too long to ship it, you know? And so I think, I mean, these are all successful companies. Like, it's not like none of it works. And I think that might be one of the challenges that we face when we try and come up with what software engineering is, because there's so many different approaches and some of them conflict. And I think one thing that would be super useful is to find like this core, because there certainly are some cores. I mean, there's some cores about how you write code, how you think about design, even if you're going to do it differently, even if you're going to test differently. And I think that's what the real challenge is. If we can kind of come up with those common cores, and okay, it's a buzzword in the US. Anyway, this common core of knowledge and the way of thinking about things, I think that might be a really cool place to start.
Andreas, you raised your hand literally a few minutes ago. I don't know if you meant to say something or not.
You're muted. Oh, I can't hear you, Andreas.
Andreas, you were muted. Maybe.
Yeah, he wasn't actually muted. Now he is.
Okay.
Okay, now we can hear
Yes.
you
So
again.
now, but I just want to say thanks. No, everything is clear right now. Pass over the token to Tim. Sorry. Right. Muted. Damn. Tim, it's the token
No,
is.
Andreas, you were talking, and I was just saying that we couldn't hear you.
Okay. Can you hear me now?
Now we can.
Okay,
Yes,
perfect.
yes.
I just wanted to say everything is clarified right now. And so passing over the token to whoever wants to have the token.
I think Mike was on.
Uh-huh. Might be.
Well, I think one question I would have is, we have like Chris Taylor and Christopher Bull and Axel and Bernd and so on in the audience. Does any of them want to say something? No? It's a quiet group. Okay. So.
Well, if you don't mind me stepping in, I think the biggest challenge that I'm facing from what I'm perceiving, so it's very much a data point of one. It's not so much the challenge of what we teach, it's the challenge of how we teach. So there was a lot of discussion about the social side and design thinking, this kind of stuff. So I know in the courses that I teach, we don't formalize design thinking, but I weave it into what we talk about. We give them projects. So, we do that project-based approach, and then we try and think about, okay, let's start thinking from a user perspective, more than just the user. Let's talk about stakeholders, let's talk about the ethics, this kind of stuff. And we weave all these challenges in, and it is very overwhelming. And we don't formalize this, and these are in small courses, and I'm not sure that we should formalize all these things. But then there's also the sides, the other thought of, okay, if we're not formalizing any of this stuff, how do we know we're doing any of these individual bits correctly? We know that we're doing some correctly because some of these people are coming out as very thought-provoking, interesting characters, and they're going into industry and doing great jobs. But there seems to be a gap in there somewhere.
Thank you. Yeah.
I saw Tony as light up for just a second there. Tony, can you hear us? Tony Cowling. No? Okay. His box went yellow as though he was making a noise, but we haven't heard from him all morning, even though he's supposed to be on the panel.
He has commented in the chat.
In the chat,
So,
yes.
He is here.
Yes, but somehow his sound isn't working. But it
Right.
just made it. It just sparked for a second there, so I thought maybe he'd get through to it. Oh, that's too bad. It might be that I think we've come to a lot of interesting, observations here, and it might be time to sort of just wrap up, because otherwise, I mean, people watching this on the video won't want to watch 25 minutes of let's just pick up random points. But I think we've got a lot of valuable stuff, and it might be worth trying to sort of summarize in wrap up statements from the panelists, perhaps. I don't know.
Okay, that makes sense. Do the panelists want to make a summary of where they think they are now?
Well, maybe I could just wrap up.
Timothy,
I mean, yeah. I mean,
Sure.
if I could just say this, and that is that I just reassert my point about potentially that we need general engineering education through K to 12. And I made that analogy to bridge building. We need to really focus on pushing education departments to train teachers. And but then the things that I picked up from the panel that I think are the most valuable from others are this idea that we should be thinking in terms of products and not projects. And that you know, there are analogies to other fields like finance, and you know, this thought that budgeting isn't the way to go. You know, I mean, that's not something that necessarily is core to this panel, but oh boy, yes, that really struck a point for me. And yes, we do try to teach kids budgeting. And in fact, I think that it's right to say that tracking is better than budgeting in many contexts, and that includes in agile software. So, interesting observation.
Okay, outstanding. Don, did you want to summarize somehow, or?
I don't know if I've got
You look very
anything
pensive.
to add. I do think that the fact that we have a lot more programmers out there that are not people that are doing programming, maybe I should say, that that they are you know, making sure that they have the software engineering skills that that they need to do when they're programming, say, in Python. I think that's one thing that I hear a lot of people, like I've got friends in climatology, and for instance, that regularly are programming in Python, even though that's not their primary job. That those people need to somehow get those software engineering skills to make sure that they get that while they're getting their while they're doing their learning coding on their own sometimes. That's the only thought that came to mind.
Yeah. Listening to that, I was thinking about the fact that they need there's a piece that I'd like people to understand where, yes, you can do this much non-professionally, but when it gets to be this big, or you're going to use it this many ways, or this, somewhere there's a boundary line where you really should get a professional in to help you out. And I'm not sure how to make that delineation, but as you point out, there are electrical engineers out there who are busily trying to code away. There are many people who they're not software people at all, and yet they're trying to use the tools and stumbling across some of the same problems we've seen so many times before. And it hurts to watch them. Some way to help them realize, okay, you've reached a point where get somebody who knows what they're doing in here, get a tester in here, get a requirements engineer in here, and so forth.
It's like people can do their own taxes, talking in United States terms, in income taxes. And of course, there's a lot more using of software, but then there's people that need to realize that, well, they really need to get an expert to do it, either help them or to do it for them, their taxes. And that type of analogy probably works to a certain degree for programming too.
Sure. Okay. So we've heard from Tim, we've heard from Don. I think, Andreas, I think that leaves
Yes.
you.
Okay, so what is my takeaway? I think it's one thing that Gerhard mentioned or stressed out. It's the fact that we need to base our teaching much more on learning by doing. I fully agree with him in that respect. And to my opinion, we should stimulate the curiosity of pupils much more. And so this is one takeaway. However, there is a question to the audience from my point of view. So what would you wish from future teachers that they are able to do? How would skills of future teachers look like, or should look like?
One point on that, it will be too late. So we shouldn't start teaching new teachers something. Is it just a generation to be too late? We have to start with the people who are in the systems now. Sorry.
I know, but how would you do that? And who could do that?
Get the experts together, have a look with design thinking, what people need. Take a small group, 10, 15 people who really want to change the world. Let them do their job. Like Timothy created a huge, cool system. Yeah? And it was him burning for that. That was my experience, Timothy, yesterday. And you need people in that burn for that and do it. And they need then the support of the whole community, money, knowledge, whatever. But we have to support the people who are really driving that.
Yes, but that's not a contradiction to my opinion, because we also need to think about the next and future generations.
Too late.
Yeah, but I would agree, Andreas. We need both.
Yeah,
and even more. No?
Of course,
because,
sorry for that.
Yeah, that's my point.
The starting point has to be quicker than the next generation.
Yeah.
Yes.
So looking at your new.
Yeah, but this is one thing that I can do, right? So I'm now in a position where I really can work on the next generations of teachers. We changed the curriculum now in Austria, so we are now teaching software engineering also in the teacher education. This is one thing that I can do. I don't have there are for sure a lot of ideas around, but anyway, so that's what. As
politics and help the politicians create good decisions. Really.
Mm-hmm.
I mean it literally. Go to the Kultusministerium, or how it's called in Österreich, and really talk to people and say what is okay and what not.
We're doing that. We have regular meetings with politicians, and then we face the problems that politicians think that software engineering or computer science is using a computer typing text. So
the good news is that there's a huge wave of young people who are super computer savvy, not necessarily, unfortunately, about programming and software engineering, but nonetheless, they are real experts at gaming and all kinds of other aspects of computing that are coming in. They're also much more liberal. I mean, they're willing to try new things. They're into climate change. They're into all of these things. And they're pushing forward. You just look at recent elections where, we saw some problems 4 or 5 years ago, but now we're seeing major shifts in the 20-somethings. I'm a little bit optimistic. And also, I think that this point about we can't teach the teachers. Well, yes, that's mostly because they're stressed out. But those who aren't stressed out, there's a good percentage who are actually willing to try new things. Same thing with other professionals. There are doctors who are stuck in their conservative ways, and there are doctors who are in their 50s and 60s who are willing to try new things. Same thing with teachers, if you just give them the leeway. So if we can alleviate teachers a little bit by giving them online learning technology that students can go in and learn to program a little bit with a teacher's assistant, make it mean the teacher don't have to be in front of the class all the time and spend a little time learning themselves. Then they can come back to the classroom saying, you know what, I just learned how to program And now I can really help you with this online stuff, and we can interactively do it together.
Well, Mike, back to you.
Time to wrap, I think. Although I don't want to have the last word. Somebody else have the last word.
Okay. I think I was making some notes when you were first talking, and you know, the question of why should I learn that really stood out for me. It was, yes, that's a key question, and it's the one that I run into when, you know, people tell me, oh, how do I use this on my cell phone? And I say, okay, you're going to have to learn this and this and this. And they say, wait a minute, why do I have to learn that? And, well, to understand what you're talking about, you need to understand this. Really? You know, why should I learn that kind of thing? The bridge building, I love that analogy. I think that's a great one. I think one thing that we talked around that I at least would like to perhaps push a little bit on is this idea that there should be a common open source body of knowledge that we can make available to the teachers, the students, everybody, and that it's, you know, well designed and intended for use, a parallel to the SWBOC, but not quite.
Yeah, but not a body of knowledge in the sense of bodies of knowledge. The problem with bodies of knowledge is that they tend to be just text. They tend to be generated by a small group of people who think a certain way. I mean, just yesterday I was attending a session on Essence, and there's a lot of great ideas behind Essence, but it's missing the modern stuff. And so there's an issue that you get the wrong people into it, and it's just plain text, and then you have people preaching and saying this is the greatest we've got, but it misses so much. So yeah, we need experiential learning based body of knowledge, maybe that is dynamically updated and agile.
Yeah, right. Something that's got a lot of the games and so forth available for them. I was also thinking about the fact that when you're teaching a class, one of the problems I occasionally run into is I've got 20 students who just need the basic stuff, and I can't, you know, I have to provide that for them. And I've got two rascals over here who have already got that, and they're ready to zoom ahead, but I can't spend time with them because of the 20 others. And it seems to me that one of the problems many teachers may run into is, how do I handle these rascals who are so bloody fast at learning it all, giving them, hey, why don't you have them do some programming, have them do a game here and stuff, might be very helpful. Something to distract the fast learners. Anyway, that's kind of a helter-skelter summary of some odds and ends that I noticed. Mostly, I want to thank everybody. You've all been very, very good about this, and I think you've contributed a number of good ideas. I'm hoping to watch the video later and try to pull it together in some sort of sensible format. If you'd like to do something along those lines, I actually made up forms to submit suggestions and so forth, but I didn't bother with those. It didn't seem like the right thing to do here. If I was running a class, I would tell you, go fill out these forms, but I won't do that here.
Yay.
Yay. I didn't give you any homework either, and all my students will tell you I always give homework. Any other last words or so? We're coming up on the witching hour or whatever it is.
If one,
I think in Munich, I did mention to my students that I was going to be running a virtual conference you know, a panel session for a conference that's headquartered in Munich, and they said, "Don't you get any beer?" And I said, "Well, I don't think so." They seemed to think that was terrible. How could I possibly be connected to Munich and not get beer out of it? I don't know. Maybe the organizers can send around beer. Elke, can you do that? No? Okay. Anyway.
Was cancelled. Did you see Tony's comment? Ask him for a position statement. He said, in a nutshell, my position is that software engineering for everyone depends on how people have to interact from the outside with software engineering, and what goes on inside software engineering is much less important.
Oh, that's a very good point. One of the interesting things that happens when you get, we had a project with a doctor who came in and said, "I've got money from Pfizer, oddly enough, and I want you to make something for me." And we said, "Okay, what do you want?" And he said, "Well, I'm not sure, but I want it to do this kind of thing." Oh my gosh. Oh, okay, sit down and let's talk about what you're trying to do and stuff. Basically, he wanted to train other doctors with his knowledge. We ended up making what looked a lot like a big game for other, other doctors to use that walked them through his diagnosis and treatment and so forth. But getting him to the point where he understood how to explain to us what he wanted took a long time. And getting my little software team to the point where they understood what he was talking about, we finished the project and I'm still not sure if everybody really understood him. He was kind of an interesting guy, especially talking about budget. He had gone to Pfizer and talked them into paying for this before he ever came to us to talk about how long it was going to take. So he had a pile of money and he wanted something from the software world. It was an interesting job. Okay. Anybody else got anything they want to toss in? Or should we call this closing?
It was great
I
chatting.
think we're closing.
Yep.
That's good.
Huh? Okay.
Bye, everybody, then.
Bye.
Thank you all.
Yeah, goodbye.
Appreciate it.
Well, you should make an announcement regarding the next panel you're chairing. Maybe there are some people wanting to share the other opinion about what is in the future of software engineering.
That's true. Thursday, same time, which wherever you are, it'll be about the same time. So Don's going to have to wake up again and everything.
Yeah.
The basic idea is simply, what should we be doing for software engineering research for the next 5 years? You know, simple question, right? I like these big questions, you know, and hopefully we'll get some ideas about what should we be looking at, how big are they, where do we think they're headed, and so forth. Anyone who would like to join us then, please do. We have a couple people, I think Timothy's going to come back and talk again. So we'll see how that works out. Okay.
Thank you, then. Bye.
Thank you.
See you then, or see you in one of the other things. Okay.
Thanks. Bye.
Bye-bye.